Hi class, we're looking at theoretical probability here today. You might remember this from the book What Do You Expect last year in 7th grade. Let's go over a few things with probability. First of all, the probability of an event, or P of the event, that means probability of the event, is how likely the event is to occur. An outcome is the result of any single trial. An event is any outcome or group of outcomes. And then a sample space is all possible outcomes. So let's look at one example here. We have the event of rolling an even number on a number cube. That's the event. The sample space are all the numbers in the number cube. And then the favorable outcomes are those even numbers, 2, 4, and 6. The theoretical probability is when all possible outcomes are equally likely. So in theory, the probability of rolling an even number on a number cube is going to be 3 out of the 6, which is 1/2. All probabilities need to be reduced. Now, with probabilities, as the closer you get to 0, the more unlikely an event is to happen. As you get closer to 1, or 100%, if you think about it, the event is more certain to happen. Okay? So 0.5 probability, or 1/2, you've got a 50-50 chance, or equally likely. So if you think about it, impossible event would be rolling a 7 on a number cube, or rolling a number, a more probable answer is going to be rolling a number less than 7. So that would be any of the numbers would fit this event here. Compliment is not, hey, I like your outfit, but a complement of an event is all of the outcomes not in the event. So let's look at a few examples of those. The possible outcomes for rolling a number on a number cube are 1 through 6. The outcomes for rolling an even are 2, 4, and 6. So the complement are the outcomes that are not in the first event of rolling an even, which would be 1, 3, and 5. Experimental probability is probability based on trials, which means you actually did something and counted it up to see what the probability was. I look out into the classroom and I say, what's the probability of being a rolling a number cube? And we look at your results. So you've actually done an experiment to collect data. If you're just thinking about all of the numbers or something like that, then that's theoretical, when you're thinking about all of the events and how likely they are to happen. Odds describe the likelihood of an event by comparing it to the favorable to the unfavorable. So like the odds of being a boy in the classroom are 1 to 1. One boy to an unfavorable outcome of 1 girl. So they're even. If I said, what's the probability of being a boy in the classroom, it would be 1 out of 2, which is 1/2. So we have half boys in the classroom or half the girls in the classroom. So probability looks at, think of probability as like percent. Odds are wins to losses. Think of it that way. Moving on to our first example, we have finding the theoretical probability. A bowl contains 12 slips of paper, each with a different name, the name of a month on it. Find the theoretical probability that the slip selected from a bowl has the name of the month ending in "ber." So we have to go back and look at all of the months. First of all, we have 12 total months. That's the number of possible outcomes. So 12 different months, okay? And then we go through our list and count how many months end in "ber." So January does not. February, March, April, May, June, July, August, September is 1, October is 2, November is 3, and December is 4. So 4 of the 12 months, or 4/12, is the probability that we'll have a "ber" month being picked. Now we always reduce are fractions. So in this case, we'll reduce the probability to 1/3. Okay? Now the complement of an event. A complement of an event. Let's think about this. For a number cube, find the probability of not ruling a number divisible by 3. So first of all, we have to think about all of the numbers in the number cube and think about which ones are divisible by 3. Okay? So the numbers that are divisible by 3 are going to be 3 and 6. So that's the probability of being divisible by 3, which is 2 out of the 6. So then how many are not divisible by 3, which would be the complement, okay? So you could take the 2/6, which reduces to 1/3, and subtract from that 1 minus the probability of being divisible by 3, and you're left with 2/3, okay, which is the probability of not being divisible by 3. Okay, moving on to example 3. Find the odds in favor of tossing a number cube and getting a number greater than 4. So favorable outcomes. Numbers that are greater than 4 are going to be 5 and 6, right? And the number of unfavorable outcomes, because it said greater than, so it can't be 4. So unfavorable outcomes would be 1, 2, 3, or 4. So we have 2 favorable to 4 unfavorable. So 2 to 4 could also be 1 favorable outcome for every 2 unfavorable outcomes. Odds are usually written in this form as a ratio written with a colon here. Experimental probability. Experimental probability is always based on an actual count of something. So here we've taken 500 belts and we've counted how many of them have no defects, which is 485 belts. So what's the probability that a belt selected at random will pass quality control? So we want to express our answer as a percent. So we're going to take the number of times the event occurs over the number of times the experiment is done, which is 500 times. So we found 485 belts that have no defects over the total number of times we looked at different belts, which is 500. And we can grab our handy dandy calculator and divide. So here we take 485 and we divide it by 500. And we're left with 0.97, which is 97%. Remember, we multiply by 100 to get our percent. Now, using that information, we can then figure out if they made 6,258 belts, we can predict how many of them are going to have no defects. So we can take the probability of no defects, which is 0.97, and multiply it by the number of belts that they made total, which is 6,258. That should give us approximately the number of belts with no defect. So we go back to our calculator and we take our percent and multiply it by 6,258, and that will give us 6,700 approximately. So we've got 6,070 approximate belts that will have no defect. Okay? Thanks for listening. Make sure you check your skills before you work on this lesson. We'll continue with probability on Monday in class.